Assalamualaikum warahmatullahi wabarakatuh. Today I will explain you about the sound systems in the physiology practicum. But we're going to talk from the module first. That was starting with the vision. We're going to learn about the physiology of the vision. So we come from the first part of the eyes first. This is when the light enters to the pupil and being regulated by the iris. So if you know that the iris is actually the color part of the eyes, so the one that have, if someone have like blue eyes, it means that the iris is having blue eyes. If someone is having like brown or like black, it means that the iris is the one who have the color. Okay. And it's actually the iris is consists of two muscular. The first one is circular and second one is radial. And the iris is actually the one who regulates the amount of the light that was actually will come in, it will enter. Okay, so like this one, if you see, so like this one, the color one is actually the iris, but the black one, which is like the hole, is the pupil. So because like the pupil is only like a hole, it means that the one who like regulate them is the iris. So that's why it says like they're being regulated by the iris. And iris is actually being controlled by the autonomic nervous system. And autonomic nervous systems actually have two types. The first one is the parasympathetic, and the second one is sympathetic. But I will just teach you this later. Okay, we're just going to go with this one. So like iris is actually having the same function as the camera aperture. If you have seen like camera, I think you know this. And the light is actually being regulated based on like how much light we need. So like if you go to a bright room, so like it means that they have a lot of light. The things that will actually happen is actually the parasympathetic stimuli. Why? Because like if parasympathetic, it means that you have a lot of light. So like you just like can like picking which light that you want to put in inside. So that's why they use the parasympathetic, because the parasympathetic is actually used when you are at rest and or like when you digest something. And what happens is actually that the circular muscles will contract and then the pupil will constrict, so like they will go like small like this. But for if you go to the dark places, the one that actually being stimulates is actually the sympathetic. The sympathetic will make the radial muscles contract and then the pupil will dilate and make it bigger like this one. So this one is actually the way how to memorize them. So like if it's like BB means like if it's bright, it means like only beat light needs. So like the pupil is also like small. But for like dark means like dark, so like they dilate. Dilate means like vasodilatation, something like that. It means like it's like becoming bigger, right? Or like you just need to know the difference in like with a cat. Like cats usually like looks cuter at night. It's because like they need more light to to see something. And then goes to the part B, which is like light is actually bent or being refracted by the cornea and also the lens. Why? Because the lens and also cornea is actually having different density with the air from the light that come in. So like it says that the light wave actually have different angles. Wait, this one. So like that light wave have different angles depending on its medium because of density. Maybe sometimes you have seen like if someone drinking a water and they put like a straw, the straw looks like being cut, something like that. That's because of this one, like the concept of the light, if they goes into different medium with different density. So yeah, that's the same goes to your eyes as well. So like the lights just like go from like many directions, and when they come into the cornea, so like this one cornea is being be will bend the lights at the first time, because like the air and the eye is actually having different density, and then the lens will bend them again, so like the image can actually lens into the retina. Retina is in here, okay? So this one is the lens and also the cornea. Okay, and then let's go to the next one, which is the light actually can change the shape. So like they can accommodate the shape, okay? If someone is actually looking far away, the muscles, ciliary muscles will relax, and then the ligament suspensory will stretch. Then they make the lens becoming more flat, okay? But if you see something near, your muscle will contract, but the ligament suspensory will be relaxed, and the lens will actually be convex or like more rounded. I will just like draw them. So like if this is the lens, this one is like more flattened, but for this one they will be like more round. Why it's like that? As it actually can be seen if you see something like close, really close. You need to be more focused, right? So that's why that your muscles will contract when you see something close. But if it's like far away, you can just seem like with some kind of relaxed situations. So that's why. This is the way how to memorize them. So like FFCC. If you have another way to memorize it, it's actually also okay. Oh yeah, it's actually having the same thing happen with someone who have like myopia and also hypermyopia. Hypermyopia? I forgot. But I will just explain this in the PPT, okay? For this one, just go with this one first. So like the basic one. And then let's go to the next one. Wait, oh yeah, this one. So it's actually when the lights comes into the retina, the retina will process the light. Okay, so retina is actually having photoreceptors, which means that the receptors of light, and these lights is actually will convert into the electrical waves, and they will goes to the brain, and yeah, you know, like to be seen as an image. And actually retina contains cone cells and such and rod cells. So like the cone cells is actually used when someone sees color, but for the red rod cells is actually being used when someone in a dim light or like want to see like something like black and white. This one is actually coming out in the pretest. So if I'm not mistaken, the questions will be what is the functions of cone cells, or like or another names of this, I forgot. And then we also have fovea. Wait, I think I have the pictures in here. Oh no. Okay, fovea is actually the sharpest visions in the retina, but in that place it's actually only have the cone cells. And we also have the macula lutea. This one is actually sharp to sharpen an image, but if we compare it with the amount of the photoreceptor, the fovea have more photoreceptor compared to macula lutea. And then this one is the cells in the retina. We have 5. The first one is photoreceptors. Like we said that they are the receptors of the light. They have 2 types, the cone and the rod. And then the horizontal one, they are the one that will increase the contrast of the image. And then the bipolar is the one who process the light into stimuli, the light stimuli. But for the amacrine is the one who regulate and also integrate the bipolar and the ganglion. And the ganglion is actually the one who process the like stimuli, and also what is this? I don't know what I wrote. An optic nerve, something like that. Okay. Is this and form the optic nerve. And after they goes with the retina, the impulse will be sent to the brain, right? So like, if we shorten, the electrical signals will go to the optic nerve, and then they goes to the occipital lobe, because this one is actually the lobe that the vision lobe, and the image will be seen. Okay. And then it goes with the hearing physiology. We come in with the outer ear first. So in the outer ear we have pinna. Pinna is this one. They are the one who collect sound wave, and they will go to the ear canal, or the other names is actually external auditory meatus, and then they will go to the eardrum. Eardrum is tympanic membrane. Like, I've heard something that my teacher said, that if someone who have like big pinna, and like like they do not go to the back, but they are like goes to the left or like right, it means they're smart. But I'm not sure if it's like right or not. But my teacher said that it's because like they actually receive more information compared to us. But yeah, let's go. The second one is the eardrum fibrate. So actually the tympanic membrane is vibrates. They make the sound wave actually make the eardrum move in and out. Oh yeah, I forgot to say, if it's like this, if you make something like this, usually it will sounds louder to usual. It means that your outer ear is functions correctly. And then we go to the middle ears bones. I mean, like, you have learned this in anatomy. So like the middle ear bones is actually the one who amplify the vibrations. We have malleus, incus, and stapes. This one is actually the smallest bones in our body. So they are the one who amplify the vibrations, and they will go to alpha window, and then goes to the fluid, which is called as a perilymbs. In a cochlea, in cochlea, so that's, oh yeah, the fluid in the cochlea is actually move. Oh yeah, this actually there will be the questions in pre-test, if I'm not mistaken. The question will be like, the stapes, the stapes bone will amplify the vibration into, yeah, you can select the alpha window. Okay. And then let's go to the next one, which is the organ of Corti. So the organ of Corti, we can say like they are the main characters of the ears actually. So like they are the one who, the main characters with the hearing process of, hearing process. So like organ of Corti is actually convert the vibrations to the nerve signals. But first of all, we have the hair cells. Hair cells, it means that stereocyla. They will bend because of the fluid movement, and they will open the ion channels and make the electrical impulse. And also we have the window of cochlea. We have two types: the oval window, the one that goes after the stapes, and the round windows. So for oval windows is, so like the steps pushing them, so like the sound will enter. But for the round windows, they will like bulge out and release some pressure. And it's also like the fluid pathway. The round window we have two types actually: round window displacement, so where the fluid goes long way around, which is helicotrema, to prevent the pressure damage. And we also have the basal membrane reflections. This one is actually the shortcut, or like the main one of the main one that usually the hearing process take. The fluid takes shortcut through the basal membrane, and then they're actually the main hearing pathway, okay? Because like they are the one who bands the hair cells that we are talking before, like this one. And for the hair, it's actually they have two types as well. The first one, the inner one, so they are the one who send the signals to the brain. So like they are working as the microphone. And then the outer one is the one who amplify the sound. So like they are the one who acts as a speaker. Well, actually, there's a term that was called as the electromotility. It is like amplify and as well as sharpen the sound by the outer hair cells. So like this one is like a unique functions that have by the outer hair cells. Oh yeah, for the I forgot to put it. Like they actually have the pathway. I will just put it so that you know what it is. Wait. Okay, wait. Alright, so this one is actually the sound. This is too small. Let's go in here. So like this one is the sound, and then it goes to your the pinna will like take all of the sounds into your ear. They will go to the eardrum, tympanic eardrum, and then to the middle bone, middle ear bone bones. You know, they will go like into the forgot. To the malleus, incus, and also stapes. And then they will go again into the oval window that we were talking before. Oval window. And then the flute will move. After the flute moves, they will go to the basilar membrane bands. So like the hair is actually bending, okay? And then the outer hair cells will amplify. Amplify means can I say amplify means like I will just say it later, okay? And then the inner hair cells will convert them to electricity, and they will go to the nerve auditory. I don't know if you have learned about this or not. If the cranial nerve actually have like the types, like their own functions, and then they will go to the brain and being here by you. Okay, it goes to the impulse which is travel into the brain. It means that the signal from your cochlea will goes into the nerve, and then they will go to the temporal lobe, and they will have a sound like the one that you hear is actually have been processed by the brain. Okay, let's go next. Yeah, so fast actually. The physiology of balance. Okay, the physiology of balance actually have happened also inside of your ear. In the inner ear, To be more specific, it was in the vestibular apparatus. So they have two organs. The first one is semicircular canal. The second one is the otolith organ. So the four semicircular canals, they're located in an ampulla. So if I'm not mistaken, there will be a pretest question for this. Where's the semicircular canals located? And then you can answer in the ampulla. So like they are the one who detects rotations, okay? They are called as the dynamic balance regulator because they are the one like because they have like three canals that detect the head rotations in 3D, three dimensions, and the fluid, which is called as the endolimbs, is actually moving when the head rotates. So like the bend hair cells in the ampulla, and they send them into the sinuses. So it happens when you spin around and you stop suddenly, you will feel dizzy because it means that the fluid will still move and making the head and making the hair cells bending. And then we goes to the otolith organs. We have two types actually, the utricle and also saccule. If the last one is called as dynamic, this one is static. So the static balance regulator is when you're not actually moving, but if you like was put in a place that make you move, how can I say? Let's just see the example later, okay? So like there contain heavy otolith crystals, and these crystals is actually can detect the head positions that was relatively to the gravity. And for the utricle, they work with horizontally, yeah, I mean like they work with the horizontal, but for the saccule they work with the vertical. So for example, for the utricle, when you sliding, it means you're not moving, like you're not the one who move your body, but the things is making you move, right? So and then when you actually you are sitting in a car and then you make it like fast, the one who handle this is the utricle. But for the saccule, when you goes in the elevator and also like in the when you jump, yeah, they are the one who work with that. Okay, let's go to the procedures. Yeah. Okay, we go with the field of view test, which is called as confrontation test. Is to see like how far you can see in all of directions while staring straight ahead. So when you do the examinations, the patients should be not moving, like the heads should not be moving, but they will see the fingers of the doctors or like the examinators, and they will move it like into the up, left, right, and etc. Is it like to see whether like they have some kind of nerve damage or not? So this one is actually the way how it works. Okay, so we have this one. Wait. This one is called as the nasal. This one is nasal field. Nasal field. Okay, and this one, and also this one, is actually called as the temporal fields. But even though like the nasal one actually will meet the retina of the temporal one, okay? Temporal retina. And this one is actually the nasal retina. So like they goes oppositely. So like the temporal will go into the nasal retina, and this one is actually the same. Your left eye nasal field will goes into the temporal retina, but for this temporal field in the left eye, it goes into the nasal retina. Okay, but somehow the nasal retina, okay, nasal retina will have some kind of crossover in here, which is called as the optic chiasm. Cross over the optic chiasm. But for the temporal retina, they will just like goes into the same site, like this one as well. You see it? Usually they will be like questioned, but there's no question in the pretest like this. If I'm not mistaken, they will be out in the post test. If someone having like if someone's eyes is actually broken, like if someone's eyes left eye is like broken, so like they cannot see, or like blind like totally blind for the left eye, it means that the left optic nerve is having some kind of lesion or damage. But if, for example, okay, this is actually like kisi for you. If the temporal field is damaged, or like cannot see anything with the temporal fields, what happened? I mean, like which part of in the brain that's actually damaged? Okay, because like they goes into the nasal, and this one also goes to the nasal. They meet in here, right? But somehow they will go in here and having some kind of crossover in here. So it means that something, the lesson, I don't know how to say it. The damage happened in the optic chiasm. Yeah, something like that. It's actually very simple, right? Sometimes they ask like, your left temporal and the right nasal is broken. Which one is actually, like the temporal left and also like the right nasal field cannot be seen? What happened? So it means that the temporal field goes to this, which is to the nasal retina. They will go in here, right? In here. But this one, the nasal field of the right eyes will goes to the temporal retina, and they goes into here. So actually the one who have something happen actually in his one. Yeah, like that. Very easy, but I think it would be, oh yeah, the name is actually this one, optic tract. So like the damage is in the optic tract, but if you answer this, I think it will be right as well. Okay, let's go to the next one. The next one is actually the eye accommodation test. So this one is actually using the Snellen test, but I did not wrote them again because I'm so lazy. Okay, so this one, they're using the Snellen test. Snellen test is Snellen, yeah, this one. So like they have like the bigger word, the bigger alphabet in the up one, and then they will go lower, This one is actually how to measure them. These words, it means that if someone actually can just read from here, but they cannot read again from here, it means that the person can read 20 meters at the distance, but for someone normal, they can read like 200 meters of this one. You got it? Oh yeah, I forgot to say that this eye accommodation task is to see that how far you can see compared to the normal person. So like, is this to see like if you need to wear glasses or not. Yeah, the Karsnallen is actually usually 6 meters being distance with us, and then this one is 6/6. It means that you can see as what normal people can see. And then yeah, like this for example, like if you could see from here, you cannot see it from here, like DEFBOTEC. So they're the one who actually being, how can I say, like being calculated, but we'll just go about here tomorrow. And this one is the value. Oh yeah, like what I said before. So like if it's like the line is actually marked as 30, ouch, 30, 30, but the visual accuracy is actually 6/3. It means that if the proponents only can see the letter in the line of dedicating the number of 30, this means that the visual is 6/3. If the proponents cannot recognize the largest letters at a distance of 6 meters, they need to the Fourier counting test. Fourier counting test, I forgot. Something like that. Just read this one. And we also have the tuning fork test. This one is actually to see how your ear works. So usually we use this one. So use the 512 hertz to actually distinguish if you have conductive hearing loss, or conductive hearing loss is actually happen in you on your outer or like in the middle ear. But if it's like sensory neural hearing loss, it means that in the inner ear or in the nerve. Okay, so it goes with the Weber test first. I forgot this one. Just go to the Weber. So the Weber one, so like they usually place the fork on your forehead, or is it on the vertex? So for normal people, usually the sounds will be equal in both ears. If it's having some kind of lateralizations, if it's like only louder in one place, in one ear, it means that, for example, if it's louder in the right ear, the possibility is that there's something conductive loss in the right ear, or there's sensory neural loss in the left ear. Okay, and then let's go to the Rine test. I don't know how to say it. So like this one is actually to compare the ear conductions. So like the sounds through the air versus the bone conductions, which is the sound through the skull bone behind the ear. So like for someone who is normal, the result is positive, which means that the sounds that we hear in the air is actually larger compared to the bone, because the air is actually lasts more compared to lasts longer. But for if someone is having conductive loss, which means that the result is negative, the the sounds that we hear in the bone is longer compared to the air. But if someone is having sensory neural loss, the air is having a longer, it's actually the same as the normal, which means that the air have longer sounds compared to the bone, but somehow the both sounds is actually weak. And then goes this one. We have the squabah. Squabah task is to compare the patient's bone conduction to the examiner's. So first of all, the examiner should have a normal hearing. So like if they have also a problem with the hearing, so they cannot do this. Okay. So if someone is having like a shortened, if the patient stop hearing before the examiners, it means that he or her have the sensory neural loss. But if it's like, if the patient keeps hearing the sounds after the examiner stops, it means that they have conductive loss. But if like both of them stop at the same time, it means normal. Yeah, that's all. Wow, so fast. Let's go with the PowerPoint. Wait, where? Okay, this one is actually some of the review. So we have peripheral nervous system, which is composed of the nerve fibers that carry information between the central nervous system and the other parts of the body. So the afferent divisions of the peripheral nervous systems send the information regarding the conditions or the change in the external and also the internal environment to the central nervous system. And this change in the external and that body detect is actually called a stimuli. And stimuli can be in the form of energy modalities such as like heat, light, sound, pressure, and also chemical changes. And the stimuli is actually being responded by the sensory receptors that was located in the peripheral nerve endings. And the receptors must convert the stimulus into electrical signals, or like the receptor potentials, so that the afferent neuron can transmit it into the central nervous system. And when the stimulus is being responded to by receptors, it means that a receptor potential is formed. And the receptor potential can trigger an action potential in the fiber process. And this process is, why doesn't have this process is actually called as sensory transductions. Well, let's go to the physiology of the vision. We will just make it faster because we have learned about this in the module actually. Not this one. But yeah, I think in your anatomy we have learned about this guy, right? Okay, so the eyes, the eye protection coat, we have eyelash. So eyelash is the one who catch the dust and also like the dirt in the eyes. But for the eyelids, oh yeah, eyelashes is this one. Oops. Yeah, this one eyelashes. Eyelash catch dust and also find dirt in the eyes. But for the eyelids is the eyes is actually protecting the eyes from the environmental disturbance such as the glare, dust, and other foreign objects. And the eyelids can close relatively to the protect of the eyes from threatening situation. And then, oh yeah, eyelids is this one, like the skin part, but the eyelashes is the hair part. Okay, and then the tears is being produced by the lacrimal glands, and they are the lubricant and also the cleanser, and also they are bactericidal, which means that they could kill bacteria. And by blinking is actually helping to spread the tears across the surface of the eye. Let's go to the next one. This one is actually the layers of the eye. If it goes from the outside to the inside, it goes from sclera, and then choroid, and then retina. On sclera, we have a thin layer that called as cornea. Cornea is the one who actually the first place where the light is being refracted, and then the choroid, which consists of iris and also ciliary body, which control the pupil into regulating the amount of the light entering the lens. And then between the cornea and also the lens of the eye, there is aqueous fluid, which they are the one who nourish the cornea and the lens of the eye. And the retina is actually the innermost layer of the eye that consists of nerve tissue and also photoreceptor, which the photoreceptor is work to convert the light stimuli to receptor potential, which is being delivered into the brain via the optic nerve. And between the lens and also the eyes, we have retina, and we have vitreous fluid. These questions will be out in your pretest. So this one is the thick like gel that the function is actually to maintain the eyeball. So that's why they are so big like this. So they are the one who maintains them. This one is the diffusion process. So at first the lights enter in the pupil. Well, the shapes of the, I mean like how big the pupil is being, so like it's actually the iris. So and then the light is being bent by the cornea and then the lens, and they are being focused in the retina, and then the receptor in the retina receive the light stimuli, and then they convert them into the electrical signals. The electrical signals transmit to the brain via the optic nerve, and the signals is being transmitted and will be interpreted by the brain as an image. Okay, this actually is just the same as the one that we talk. Let's go next. Oops. Yeah, it's just the same actually. Oh yeah, this one. I want to talk about this one. So this one is pathological conditions. If someone is having myopia means that they having some kind of difficulties to see something far. In people who have myopia, the lens cannot be flat enough, or like the eyeball allows that the focus of the image fall behind of the retina. So this one is for someone who is normal, so this just go right into the retina in here. In here. But if it's like someone that having myopia, so that's how can I say? See, they will go behind the retina, which mean this one, like see, oh yeah, behind the retina in here, yeah, like goes out of them. But for someone who's do you know what does it mean flat? They cannot be flat, right? As like we said before, like if someone sees something like far away, it means that the ciliary muscles will relax and the ligament suspensory will contract, and they will make the lens become more flattened. But in this case, if the lens is not being flat enough, so that's why they just like goes with this one. But if someone is having hypermetropy, it means that they are not strong enough to convex them, because like if someone sees something close, and then the ciliary muscles will actually contract, and then the ligament suspensory will relax, the lens will be convex. But because like it's not like good enough, then the image will actually falls in front of the retina, and someone will use the contact lens of plus, but if like they have myopia, they will use the concave lens. Most of like young people, or like they use, if like you see them actually wearing the glasses, usually because of they have myopia, this one, and they use the lens, the minus lens. But for the hypermetropy, I think it's a bit rare for someone who is young having this one. Usually this one is happen with someone's old. Okay. Oh, skip money. Okay, this one is actually the cells of the in the retina. Okay, next. Yeah, this one is actually the blind spot, and this one is macula lutea. But we actually have also the fovea. Fovea is, I don't know where is that. Oh yeah, I think if you know why they are being called as blind spot, it's actually because they don't have photoreceptors at all. Yeah, so that's why. Yeah, this one is actually the one that we were talking before, like how the fields of temporal and also nasals is work. Yeah, okay then. Okay, that's all. Let's actually talk about the pretest. But wait, how can I? Here. Let me see first. Physio. I will just say the question, okay? Because it's so night, so yeah, I want to sleep. So for the first question, you can find the questions by the answer by yourself. The functions of corn and root cells. You should know like each of them, like this one what and this one is what. And number 2 is the functions of aqueous, I don't know how to say, and vitreous humor. And then number 3, I think we have learned about this, like if your afferent neurons carry the auditory signals from the hair cells out, from the hair cells, it means that they're going out of the cochlea and will be travel into, they will go into the auditory nerve. Okay, the question just like neuron carry auditory signals, right? And then so like from hair cells, the afferent neuron will carry the auditory signals, and they will go out of the cochlea to the this one, nerve, auditory nerve. That's simple, but don't just like make it end like this. You should put the nerve as well. And number 4, functions of the apa sih namanya, semicircular canals and the otolith. So like you have to know like the difference. They will ask one of them. Number 5, functions of pinna. Number 6, yeah, the one, you know, like this, after tape bond, they will go where, you know, like blank window something, find it by yourself. And then the, you know, the balance vestibular apparatus consists of what? And number 8, semicircular canals is located where? Number 9, the radial and circular muscles contractions of relaxations will be regulated by what system? Well, the answers will be like sympathetic, also parasympathetic nervous system, but I'm just so lazy to write them. And then number 10, the fovea, I mean, like, this actually the questions will be like true or false. The question will be, is it fovea the one who have the least photoreceptor? But just answer is false. Okay. Okay, that's all. Thank you so much. Bye bye.